Hello, Precal. Today we're going to be talking about the properties of logs. We're going to review these laws of logs very quickly, and hopefully this will help you get through your homework assignment. In subsequent classes, I will dive a little deeper into these topics, but I just wanted to give you guys a little brief overview of how to do this so you can tackle these homework questions. So let's take a look at it. The big deal here is this right here, okay? And essentially, what we're saying is that if you multiply the arguments together, you can rewrite them as the sum of two separate logs. When you divide, you can write them as subtraction. And when you raise to a power, you can say it as whatever the power you're raising it to times the log. You'll recall that these rules also coincide with the rules of exponents, because logs are just basically the inverse of exponents. So you can see the similarities there. Okay. So what I'm trying to say is if you see something like x to the fifth times x to the third, that is the same thing as x to the 5 plus 3. That's what this is saying. When you see x to the fifth divided by x to the third, that's the same thing as x to the 5 minus 3. That's what this is saying. And when you see x to the fifth raised to the third, that's the same thing as x to the 5 times 3. That's what this is, the last one is saying. Okay, so that's kind of a way to keep it memorized in your head. One last comment about this to kind of help jog your intuition here. I always like to say subtraction is correlated to division, addition to multiplication, multiplication to exponents. Okay, so if that helps you, fantastic. If not, I hope you find a way that works for you. All right, so it says evaluate each expression. So if I give you the sum of these logs, then we know that that is the same thing as log 3 to the 3 times 9, or log to the base 3 of 27. Okay. B, we know that if we're subtracting, then we're dividing. So this is the same thing as saying log base 4 of 16. And the last one, we know, we write it this way, and we know that this is also, we can take this, put it on the top, so we can write this as log 8 raised to the negative 2/3. Okay? And simple as that. Can we break these down further? Absolutely. So for this first one, 27 is 3 to the third, so this is just going to be 3. 16 is 4 squared, so this is just 2. This one, because remember, if there's no base written, this is log base 10. This doesn't come out to be anything super clean. I mean, we can clean up 8 raised to the negative 2/3. 8 to the 1/3 is 2. 2 to the negative 2 is 1/4. But you can't do anything with log 1/4 without a calculator. Okay. Again, I'm not too concerned with what they're equal to. What I'm concerned with is your ability to break it down. One other comment on this, I'm just looking at this and just trying to show you guys different ways of thinking. We can confirm, I said that this is 3, right? You can confirm this because you said, we learned the other day that if the base and the argument are the same, it's just the exponent. So the first one's just 1 plus, and this one's 3 squared. So with these together, this is just 2. So this is 1 plus 2, which is what? 3. So I just want to stress things like that because I think it's pretty cool to see how you can think in different ways and they give you the same result. And that should be the case always. All right. So on the bottom part, example 2, we're doing the same thing. It's just on the bottom, we're doing it in reverse. So when we divide, we know it's subtraction. This is compounding steps. So we can take the 10, we can put it in front. So this is 10 log base 2 x. I think I said xy. I can't see. Yeah, xy. And then we know when we multiply, this is when we multiply, this is we add them. So remember, you have a 10 in front of both. So I'm going to put them in like parentheses, or in this case brackets. X plus log base 2y. And if I wanted to go one step further, then I could say them 10 log base 2x plus 10 log base 2y. Okay? Let's do C. I'm going to have to write C off to the side here. So ignore example 3 for right now. We'll go back to it. Log base 6 square root x minus 1 over x plus 1. Now on this one, we can rewrite this as log base 6 parentheses x minus 1 over x plus 1 raised to the 1/2. So following what we did in part B, where we put the exponent in front, we'll do the same thing here. So we have 1/2 log base 6 x minus 1 x plus 1. Again, when we divide, we subtract. And because this 1/2 is affecting both, we got to keep it in parentheses. And if you wanted to write it out like this, you can at the end. So I'm just distributing the 1/2 into both. Awesome. Okay. All right. Let's see here. The last one is, well, you know what? Let's just take a picture of this. One second. So if we look at this one combined to a single log, so we're doing basically with the problem that I just did, I'm doing in reverse, right? So I can write each of these. Well, let's do this. Let's clean the inside part first. So we know we add. Actually, if I'm going to clean the inside part first, I want to start with this right here because of the 2. I'm going to go ahead and rewrite this as log base 7y squared minus log base 7z cubed. So I'm going to move those above, and the purpose behind that is we want it all to be written in terms of the argument being affected, right? Next, I'm going to distribute the 2 into each of these. And so we're going to get 2 log base 7x plus 2 log base 7y squared minus 2 log base 7z cubed. And from here, the 2 is going to go here, the 2 is going to go here. So this is going to become 4, and this 2 is going to come up here, which is going to become 6. So this becomes log base 7x squared plus log base 7y to the 4th minus log base 7z to the 6. And if you had a question about does that negative go with the 6 or not, you actually can do it both ways. I'm going to keep it like this because I think it's a little clearer. But you actually can do it both ways. Again, at the end, we said addition is multiplication, subtraction is division. So this concludes with log base 7x squared times y to the 4th over z to the 6. Cool. And that's my answer. So let's look at the next page. There's one more rule that we want to talk about, which is the change of base. And all this is saying, I like to think of this as log a over, actually, let's do it this way. Let's call this little s and this big B, so big over small. And it's just the log of the big over the log of the small. And all of this a written this way, then this way, then this way. Remember, ln is just log base e to the x over log base e to the b. All of these are saying is that the base doesn't matter. You can make the base, if you want it to be 10, as it's written right now. Notice if you don't have anything written, it is 10. That's fine. If you want to put an e here, you can put an e. If you want to put a 5, whatever. Okay. But it's just log of the big over the log of the small. So log base 6, 8 is the same thing as log 8 over log 6. Log base 9, 5. Notice when I say big over small, I'm referencing font size, not actual number. That's essentially it. This is useful. This used to be really useful at the high school level with old school calculators because they didn't have the base. Most of y'all have these TI calculators that now can just do it directly, so it does directly. But you're going to see problems in the future that you will have to directly use. You'll have, say, variables. And so if I ask you, for example, to change, actually, like here, if I gave you this question, for example, on a test, calculator's not going to help you because you have to do it in terms of variables. So that's the significance, is the abstract notion, which can be used in more sophisticated questions, which we may see in the future. Okay. All right. Just a quick little summary of what you're doing for your assignment today. And I will see you guys next time, hopefully tomorrow in class, if you're watching this today, for the lesson for today. Or I will see you in the next video if you're watching this just to get some help with logs. All right. Bye-bye.